And my name is Muhammad Ilmaruzai bin Rusdi, and my student card is 2024 644 and 268.
My name is Muhammad Zarif Adili bin Zaidi. My student ID is 2024441524.
Okay. Hi, my name is Nur Kiranisha binti Kamazuki. My student number is 2024407062.
My name is Nur Ainasya binti Muhammad Nazaruddin. My ID number was 2024421616.
Okay, so I will briefly explain the structure of our presentation based on the table of content shown on this slide. Okay, first we will start with the introduction, where we will explain the background and overview of our smart parking management system. Okay, second, we will move on the objective, which highlight the main goals and purposes of developing the system. Okay, then we will present the flowchart to show how the system works step by step, from vehicle entry until parking allocation. Okay, next we will discuss the source code, where we explain the logic and programming used to develop the system. Okay, this will be followed by the sample input and output to demonstrate how the system functions using real examples. Okay, finally, we will end our presentation with the conclusion, where we summarize our project and its overall contribution. That's all for our table of contents. Let's proceed with the introduction. So, I would like to introduce our project, which is the Smart Parking Management System. This system was developed to optimize the allocation of parking spaces in urban areas. As we know, finding parking in the city can be time-consuming and often causes unnecessary traffic congestions. Therefore, our system aims to provide a more efficient and systematic solution to this problem. The Smart Parking Management Systems works by storing complete information for each parking space, such as whether the space is vacant or occupied. In addition, the system records the entry and exit times of vehicles, allowing us to accurately track how long each vehicle stays in a parking space. When all parking spaces are fully occupied, the system introduces a queuing mechanism, this feature helps organize waiting vehicles and ensures that they are assigned to available parking spaces efficiently without causing confusion or congestion. Furthermore, the system provides real-time updates on parking availability. This reduces the time drivers spend searching for parking, which helps improve traffic flow and reduces congestions in urban areas. As a result, it also helps save fuel and support smoother vehicle movement. Overall, by improving parking efficiency, reducing traffic congestion, and supporting better decision making for both drivers and parking management, our Smart Parking Management System contributes to Sustainable Development Goal 11, which focuses on creating sustainable, safe, and resilient cities. That concludes the introduction of our project. Thank you. In this slide, it shows the main objective of our Smart Parking Management System. The first objective is to calculate the total parking fees based on the vehicle's entry and exit time. This allows the system to automatically determine accurate charges without manual calculation. The second objective is to search for vehicles using their number plate. This feature helps parking management quickly locate a vehicle and retrieve its parking information efficiently. The third objective is to allocate vehicles to available parking spaces. By doing this, the system ensures that parking spaces are used efficiently and vehicles are placed in the correct areas. Overall, these objectives aim to improve parking efficiency, reduce manual work, and provide a more organized parking management system.
Next, I will explain the flowchart. The smart parking system starts by displaying a menu that allows the user to choose from several options, including displaying parking status, viewing the waiting queue, parking a vehicle, removing a vehicle, searching for a vehicle, or exiting the system. When the user selects option 1, the system displays the current parking status, showing the occupied and available parking space. If the user selects option 2, the system checks the waiting queue. If the queue is empty, A message indicating that there are no vehicles in the waiting queue is displayed. Otherwise, the list of vehicles in the waiting queue is shown. For option 3, the user is required to enter the vehicle plate number and entry time. The system then checks for available parking space. If a parking space is available, the vehicle is inserted into the parking area. If no parking space is available, the vehicle is added to the waiting queue. When option 4 is selected, the user enters the vehicle plate number and exit time. The system removes the vehicle from the parking area and displays the vehicle exit information. For option 5, the user enters the vehicle plate number to search. The system searches for the vehicle in both the parking area and the waiting queue. If the vehicle is found, the vehicle details are displayed. If the vehicle is not found, an appropriate message is shown. If the user selects option 0, the system displays a message and terminates the program. Any input other than the valid options will result in an invalid input message. The system continues to run until the user chooses to exit. That's it.
Now, I will explain the source code implementation of our parking system. Our system is written in Java and uses 4 main classes to manage the parking operation efficiently. The first of all is Smart Parking App, Parking Slot, Linked List, Queue, and lastly, Node class as a supporting structure. First, I will explain the Smart Parking App class. This is the main class of our system. It controls the whole program flow, including displaying the menu, reading user input, calling functions like park vehicle, remove vehicle, search vehicle, display parking status, and display waiting queue. Inside the class, we use a linked list to store the parking slots and a queue to store vehicles that are waiting when parking is full. This class is also reads data from the files, calculate parking fees, control the entry and exit of the vehicle. So basically, this class is the brain of the system. Next is the parking slot class definition. This class represents one parking slot in the system. Each parking slot stores vehicle number plate, entry time, exit time, and parking status if occupied or empty. This class contains constructor, getter acceptor, and method to calculate parking duration and fees, and a toString. So each object of parking slot represents one car in one parking space. Next is a queue class. Queue is used to store vehicles when parking is full, and it applies a FIFO concept, which is a verse in and verse out. So the first car that enter the queue will be the first one to get a parking slot when one become empty. This class contains functions like enqueue to add a vehicle to the queue and a dequeue to remove vehicle from the queue. So this ensures fairness in the waiting system. Lastly is the linked list class. We use linked list to store all parking slots dynamically and manage adding and remove vehicles efficiently. Why we use linked list? Because its size is dynamic and easy to insert and delete data, more suitable than array for the system. This class contains functions like add node, remove node, search vehicle, and display parking list. So linked list is used to manage the parking area. And here are the node class which is the supporting for the linked list.
Hi, my name is Muhammad Zarif Ali bin Zaidi. I will continue to explain about sample input and output. So this is our main selection. So number 1, when user enter number 1, the system will go to display parking status. Number 2 is for display waiting queue. Number 3 is for park vehicle. Number 4 is remove vehicle. Number 5 is search vehicle. And if user enter a 0, the system will exit. This is a sample output if user enter choice number 1. The first, we show a slot ID After that, we show a plate number for that car. After that, we show a status for that parking. Last, we show a entry time that recorded for 24 hours format. This is a sample output if user enter choice number 2, which is to display a waiting queue. The first output is notice about if waiting queue is empty, and the second output will be show if waiting queue is not empty. Next, for choice number 3, which is to park a vehicle. First, user need to enter their plate number, and that user need to enter the entry time. If parking is full, the system will show the notice that say no available parking space and the vehicle added to the waiting queue. If parking has an empty slot, the output will say the vehicle parked at slot that have a parking. Next, for choice number 4, which is to remove vehicle. In this screen, show that a vehicle exit process for our smart parking management system. First, the output will show the slot ID where the vehicle was parked and their plate number. After that, the output will show entry and the exit time, the duration of stay, and lastly, the corresponding of the parking fee. If there a vehicle waiting in the queue, the system immediately assign the newly available slot to next vehicle. And last is for choice number 5, which is to search a vehicle. First output will show if vehicle is inside parking. There will pop up their slot ID, their plate number, and the entry time. If vehicle is not inside parking, they will be in the inside waiting queue, which is they will pop up the notice about their queue number.
Next, for the conclusion, the Smart Parking System Management delivers an organized and effective solution to urban parking challenge by utilizing real-time data management. This approach allows the system to monitor parking availability accurately and respond promptly to change in vehicle flow. Next, efficiently supports core operations through a structured parking slot class, which ensures systematic handling of vehicle entry, parking status, and exit process. In addition, the use of a linked list enables flexible and scalable management of parking slots, allowing the system to adapt easily to varying parking capacities. Implement a QA to fairly manage waiting vehicles during peak occupancy. This ensures a first-come, first-served process, promoting fairness and preventing congestion at parking entrance. The system optimizes parking use, reduces traffic congestion, and lowers fuel consumption caused by drivers searching for available parking. By addressing these issues, the Smart Parking System aligns with Sustainable Development Goal SDG 11, Sustainable Cities and Communities, contributing to safer, more efficient, and environmentally friendly urban environments. This project provides a practical and scalable solution that meets both functional and societal goals. That's it from us. Thank you.